Hey guys, welcome to Great Learning. Blockchain is one of these technologies that established new ways of how you can work with data handling and ledgers, correct? Now, it is no doubt that blockchain is one of the fastest growing IT domains in today's world of technology itself. Blockchain became very popular, if you remember, back in the day with the rise in cryptocurrency popularity as well, and of course, it has held its ground ever since then. Now, blockchain is very powerful at solving a large amounts of problem, and of course it can do it very well. But to do this, you are going to require a good amount of knowledge about how blockchain works and everything, all the concepts that surround it as well. Keeping this in mind, we here at Great Learning have come up with this tutorial where we'll be discussing about blockchain in detail. Now, through this, you will be able to learn all of these important concepts of blockchain and of course start using them effectively as well. Now, before we get started, I want to introduce you to Great Learning Academy. This is a free initiative by Great Learning where you get access to over 200 plus courses with 1000 plus hours of free content on all of the trending high demand domains that we have, be it data science, machine learning, artificial intelligence, programming, cloud computing, digital marketing, DevOps, management, and a lot more absolutely free. Now, we have award-winning academicians and leading industry experts who design all of these courses. And the best part, you can also get a free certificate of completion when you enroll and complete all of these free courses. You will of course get access to all the presentations, be it the code notebooks, data sets, and the quizzes as well. So as of now, we have courses in English and Hindi. You can use these multilingual approach to make sure that you have the best learning experience possible in the language that you are comfortable with. So make sure you check out the description box of this video to get access to all of the relevant courses on Great Learning Academy. So what are you waiting for? Register now and start your learning journey today. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.
Hey guys, and welcome to the blockchain course. My name is Mayank and I will be your helper and guide throughout this course. This course will be a fundamental course in which we are going to learn about what blockchain is, what are the different technologies behind blockchain, and we will also see what is the difference between the traditional technologies and the current blockchain technology. By the end of this course, we will also go through some of the use cases related to blockchain. So you will get a better understanding of how blockchain is being utilized under different organizations. Before we understand what blockchain is, let's just talk about database system. Database system is something which blockchain is taking in as a concept and building on top of it. So what are database systems? Traditionally, a database is a data structure which is used for storage of some information. In the traditional times, we used to have a flat file. Whenever I call it as a flat file, this means that we have something like a text file where people used to store data and then retrieve the data for their web applications or mobile applications. Now the database systems has grown a lot. So we have different kinds of complex database system where we can store relationship database or non-relationship database. But typically, if you want to define a database, you can call it as a data structure, which is used for storage of information. This data structure is available electronically on a computer system where different web applications and mobile applications can interact with the data and fetch the data for their own purposes. Mostly the databases are built upon hierarchical system where we are going to store some simple information related to the application which we are dealing with. For example, if you have a IMDb web application. So you will have a movies database and you might have a users database. And you might also create a relationship between users and movies where some of the users are fetching different list of movies as per their needs. So these are some of the things which we can do with the database. Typically, the databases are organized at DBMS. DBMS is known as a database management system. It could be a command line based system or it could be a GUI based system, which is used by us to interact with the databases. Inside the databases, there is a concept which is known as a table. What is a table? A table is a collection of related data which is held within the databases. Tables are made up of two things. One is known as columns, the other one is known as rows. Columns are used to define the data fields and the rows are used to define the actual data. For example, if you have a users table, then you can define name, address and phone number as column, which will be defined for each user, and single entry of a name, for example, which is showed here on the screen, John Smith, with the address and the phone number will be taken as a single record or a row within the data here. Tables are mostly organized in a way which are storing the similar kind of data. So for example, again going back to our IMDb, then you can have a movies table which will be storing the information about movies, and you can also have a users table which will be storing the information about the users. Now coming to some of the characteristics of the database. Whenever we have a database with us, there are some of the primary characteristics which are employed by the different users and the systems who are interacting with the databases. One of the primary characteristics of database is that the database can easily be modified, managed and controlled. You can enter new users inside the data, you can modify those users, and you can even control the users that what kind of user will have what kind of permissions related to your applications. Moreover, each database also has a function which is known as an administrator. Administrator is basically a user of the database who has the complete control of the database. He can go ahead and delete the database, he can create a new database, he can modify the different entries with the databases. So he has the complete control related to the CRUD operations for all the records which are stored with the database. Administrator is also responsible for providing performance and managing the size of the database. So they make sure that the data is retrieved from the database in such a manner that the performance is maintained. Moreover, there is simple sharding or simple normalization happening with the database to make sure that the data is easily retrievable and the size of the database does not exceed our limits. A database could have many other roles. I am just discussing here about two major roles. One is the user and the admin. You can also have the operational roles and the control roles. And the primary thing to always remember about a database that whenever we have a database, you can easily go through the whole data. You can modify the data. You can update and delete particular record with the database. The primary use of database is to store some kind of information related to the web application. There are many different databases available in the world. Some of the primary databases are the Oracle database, SQL Server, MySQL, and even you have non-relationship databases like MongoDB and DocumentDB, which will help you to create your use cases and employ your applications. In this image, we are just showcasing you a typical database topology. If you just have a look around the image, you will notice that there is a host server, which is defined as a backend server, which is used for hosting the DBMS system. DBMS again is a database management system, which is actually storing the database where the information is being stored. Then we have three different clients which are connected to this DBMS server. You have the client computers who are accessing the database through some kind of command line, or you can have it be interacting with the web interface. So this typical architecture is known as a client server architecture, where you have a single database and different clients are connecting to it. Now, if you look at this client server architecture, you will notice that there is a typical problem here that we have only one central system to hold the database. If this central system is attacked by the hackers or somehow the information is modified with this central system, then everyone who is actually interacting with this database will have that modified information. So this is a point of concern for us because we have a central point where the attacker might attack and change some kind of data. Moreover, if somehow some of the developers or some of the system administrators users who are working with the database modify those information, then again the whole client systems, the different client systems which are connected to the database will have those modified system. So this is one of the problems which are existing with the database. Now you have learned about the traditional technology, which is database, and you have seen that how the topology for a traditional database system works. So you will mostly have a client server architecture where the server is just one single point or a central point where different clients are connected to it. Now let's go and understand what blockchain is. We will just go briefly through the blockchain and see what are the different things behind the blockchain. So what exactly is blockchain? Everybody has heard about blockchain. Everybody has also heard about Bitcoin. Bitcoin was the first use case for blockchain, which actually introduced us to the concept of blockchain. And Bitcoin came into being by the year of 2009 by an unknown person who was known as Satoshi Nakamoto. Currently, blockchain has grown a lot apart from Bitcoin, and multiple organizations are using blockchain to tackle their problems and provide better solutions. So what exactly is blockchain? Whenever we discuss about blockchain, what is blockchain? Blockchain is not a cryptocurrency. Cryptocurrency is basically a use case of the blockchain. There are many other use cases of blockchain. You can use blockchain under supply chain. You can use blockchain under trade agreements or letter of credit. Or even if you want to build, you can build up a mathematical calculators using blockchain. Behind the blockchain, there are three primary things which work with the blockchain. The first thing is that all the data which is shared on the blockchain is recorded permanently. When we say permanently, that means nobody can modify it, nobody can delete it. This is one of the primary characteristics of blockchain. The second important characteristic of blockchain is that every data which is present on the blockchain is cryptographically secure in a chronological order. So each data is connected to each other. And the third major thing is that the blockchain removes the central parties or intermediaries, and it creates the trust through the cryptography which is working under the blockchain. Let's take a real life example for this. Let's take the example of a book. So whenever you have a book, take this book as a database. So you have different pages inside the book. Those can act as tables, and there is different context written on those pages that can act as the rows inside your table. So whenever we have such a thing, your book is the complete database which you have. The problem with this is that if you somehow remove any page inside the book, then your data is going to be missed, and you can easily remove the pages because you are the owner of this book. Now, if you change this example and you take the scenario where this book is actually stored inside a library. So what happens is that you go to the library, you borrow the book, and then you write your name on the library card that you are the person who is borrowing the book. Now, if you borrow the book and remove some of the page from the book and then return it to the library, then what's going to happen? That the next person who is borrowing the book, he can easily verify that something is missing and this page is missing, and they can easily track you that you are the person who has borrowed the book, and then this whole page is missing from the book. Now, coming to our example, taking this example to the blockchain itself, you take this book as the complete blockchain. Each page inside this book are linked to each other. So you have page number 1, 2, 3, and there is a chronological order maintained within the book. Same is the case with the blockchain. You have a concept of blocks under blockchain. What is a block? Block is just a storage of information which have different kind of information with it. We will discuss about blocks in the later part of the course. But take these pages as blocks. There are different blocks under the blockchain which are chronologically linked to each other. And then each page has some kind of context on top of it. And you can take this context as transactions. So you have different transactions written on top of the book. Now, if you modify this, if you want to delete this, then the next person who is borrowing the book can easily verify that this is not supposed to happen, and this is not the right, or you can say this is not the right thing which has happened within this book, and they can easily track you. And that's the primary concept of blockchain too. Blockchain has multiple people connected to each other, and all these people are sharing the same database. Let's say you and me are connected to this system. So I am also having the same database and you are also having the same database. Now, if a third person is connected to the system, that person will also have the same database with him. Now, if I try to modify something is in this database, what is going to happen? That the third person and you can easily verify that this was not supposed to happen, because you also have the copy of the same database, and you will find me and take me as a culprit and remove me from the system. And that's why we call the blockchain as immutable, because now if somebody tries to modify it, then all the people inside our scenario can easily verify that. Now, if you take into a global scale that supposedly almost 100,000 people are connected together, and those 100,000 people with their laptops are holding the same database. So if somebody posts any kind of data, this data is shared across all the 100,000 people who are connected. So what's going to happen? That if somebody tries to modify this, then all the people inside our system can verify this, that this is not supposed to happen, and they can remove the culprit from the system. So that's what exactly blockchain is. Now, if we look at the current banking system, if you look at the image here, you will see that we have two users. And what is happening with the system, that the first user is paying some money to the second user. So the first user is transferring $100. Then we have a trusted third party in between, which is acting as a bank, who deducts some kind of fees with this, and $2 are deducted, and then the $98 are transferred to the second person. Now, if you see the problems with this system, you will realize that these banking systems has some kind of fees associated with this. And this is a very heavy fees. Currently, we are only talking about $100. Let's say it's $1 million. Then the banking fees will be much high. Moreover, the transfer of money also takes time. So there is some process included if you are doing a very large transaction. And the final thing is that we are trusting a third party to do our transactions. We are making sure that this bank is secure. If this bank is not secure and this is a malign bank, what is going to happen? That our money will be lost. So we have a trusted third party which is introduced with the system. So this is our current banking system. The problems with the current banking system, the first problem is account hacking. So we have seen a lot of cases where the accounts are being hacked and the money is being transferred to different attackers. So they can do different kinds of cybersecurity attacks to hamper that. Then we also have internet frauds where the people try to just do some kind of gullible activities and they try to fraud the people and the victims are losing money. Then we have high transaction cost, because whenever we are transferring, we have a central party who is actually helping us to transfer. And it also takes a lot more time if our amount is very high. And finally, we have created a dependency on the bank. If you take one more example, you can take the example of a football field. So two teams are playing against each other and we have a referee inside this field. Now the problem is that this referee is the central point for us. This is the intermediary for us. Both the teams are trusting this intermediary. Both the teams are making sure that this intermediary is going to take the correct decisions. But what will happen if this intermediary is not taking the correct decision? If this referee is partial towards one team and it's making sure that the other team loses. So that's the problem which we have in the current world, that we have central parties, we have intermediaries which are actually working in a fashion where we can be benefited or we can have some kind of loss because of those central intermediaries. Now, if we talk about the banking system using blockchain, now you have seen the traditional banking solution where we have a central bank which is used for the transfer. Now, if we come to the new version of the banking system, you can see in the image here that instead of having one single person hosting the data, we have different kinds of nodes organized here. You can see that there is node 1, node 2, 3, 4, 5, 6. Whenever I say node, I am just meaning that this is a computer system holded by any user. As I told you, the blockchain is basically that different users are holding the same data. So all these computer systems are connected to each other. You have 10 or 15 different kinds of computer systems connected to each other who are holding the same data. Now what we can do that each new user who is connected to the system, like Alice wants to upload a fixed deposit, or Eve wants to inspect her insurance document, or Bob wants to deposit money, then these transactions will be shared with all these computers. Now the major benefit of using such a solution is that if somebody tries to modify it, he won't be able to modify. Moreover, we are removing completely the central trusted parties. We are removing the intermediaries. What we are doing is that we are trusting the system itself. So it could be a behavior where we can see that suppose 10 computers are connected together, and from 10 computers, if 6 computers agree that the data is correct, then we can be sure that this data is good, and then we can upload it on top of the blockchain. So this is the new blockchain banking system which can happen from the traditional one. There are many benefits from the traditional one. You can see that we have removed the central parties, we have removed the concept of where we have intermediaries. Moreover, blockchain is based upon cryptography. So the principle of account hacking or frauds are very difficult on top of blockchain. Even for the frauds, through blockchain, we are able to track everything. So that's one of the major benefits which we get from the blockchain. Now coming to how blockchain solves the current problem. The first thing is that the blockchain is based upon cryptography. Whenever we have blockchain, we are actually dealing with cryptography. Each data which is used with the blockchain is encrypted and then uploaded on top of blockchain. Different kinds of blockchain projects have different kinds of protocols, and mostly it is present that the data is being encrypted and then uploaded on top of the blockchain. Moreover, we are removing the central party because we have multiple machines now connected to each other. And then we also have a very low transaction cost compared to our traditional system. Supposedly, if I'm transferring $1 million from the traditional bank, the fees is going to be very high. But if I'm transferring $1 million using the blockchain, then the fees is going to be very low compared to that. And finally, the central parties which we have removed, we are making sure that the system is trusted itself. We are not dependent on any third party to help us do the different scenarios. We are only trusting our system itself. So summarizing blockchain, what blockchain is. The first point is that this is a digitized store of information in form of transactions. Whenever we say a transaction is like a single record in the blockchain. Like in databases, you have the records inside the table. The same case is with the transactions. This is a single record which is stored digitized because we are just sharing the database to each user. The second thing is it's distributed. So nobody controls it. The people who are connected inside the blockchain, everyone has the same copy. So together they are controlling it. The third thing is we have a concept of consensus algorithm with blockchain. This consensus algorithm, we will understand this consensus algorithm in the later part of the course. But for a general understanding, you take it as like supposedly if 100 people or 100 different computers are connected together. So consensus algorithm works that if somebody uploads a new transaction or a new record on the blockchain, then this will be verified by all the 100 users. This will be verified whether the person has the account balance to transfer the cryptocurrency. It will be also verified whether the second person who he is transferring to is available in the system or not. So all the different checks are going to take place. And after that, we say that if 2 by 3 of the total people agree for this transaction, then we can easily upload this transaction over the blockchain and everybody will share the same record. Now, there is another thing within the blockchain, as I told you, that these records are chronologically linked to each other. Whenever we say chronologically linked to each other, what is happening that if you take the analogy with the database versus the blockchain, table versus the block, and then you have the records versus the transactions. So each block has a set of transactions included between them, and different kinds of blockchain projects using different kinds of protocols for the block. For example, with the Bitcoin blockchain, we normally follow the process that each block is of only 1 megabyte. So if 1 megabyte of data is included into a single block, then this block is considered to be done. Then this block is gone to a process which is known as a proof of work, and then different kinds of mathematical computations happen using this process, and finally the block is stored on the blockchain. But the major concept is that each block inside the blockchain is linked to each other. So whenever we are storing a block, then we are creating a new block. Within the new block, we will always include the hash of the previous block. That's the main concept, that everything is linked to each other. So everything inside the blockchain will be in a chronological order. Now let's say my blockchain is working on the principle of 100th block. So I am at the 100th block, and you decided to modify this blockchain. You decided that I want to change some kind of transactions within blockchain. Let's say you modified the transaction at the 100th block. Now the problem is to make sure that your changes are under effect, you need to modify all the last 99 blocks within the blockchain. You need to make sure that all those 99 blocks are modified as well, because we are using the hashing functionality. So what is happening, that those hashes are already stored with the blockchain. And how does the hashing work? Hashing works on the principle that it converts a variable length of data into a fixed length. So we have the process where anytime we store a hash, and if we change a single bit of information, then the whole hash will be different. So if you try to modify any transaction, the hash will be different. Now this hash is linked to the previous block. So the previous block hash will be also different. And then the 98th block hash will be different. 97th block hash will be different. So you have to go and modify each block itself to see that how blockchain is working. This data is always stored under the chronological order. And the final thing is that this data is present with everyone. So everyone can view all the different transactions which are part of the blockchain. So if I want to define blockchain under a single term, I can say that the blockchain is a digitized, distributed, consensus-based secure storage of information, which is protected from revision and tampering over a peer-to-peer network. When we say such a definition, we have included the digitized information. Distributed means that everyone is sharing it. Consensus based is that everyone has a vote on the secure and correct data. Protected from revision is that nobody is able to modify it. And over the peer-to-peer network is basically the people who are connected to the system has the access to this system only. Nobody else has the access to the system. So now we have seen that what is a database, and we have also gone through that what is blockchain. Let's go ahead and see what is the difference between a database and a blockchain, and how blockchain can be utilized where the database is providing some kind of limitations for the organizations. So a typical database architecture looks something like this. If you see the image here, you will notice that we have a bank which is acting as a database, and then we have 4 different clients which are connected to this bank. So if you see the architecture here, we have a central point where the attacker could attack and hamper the whole system, because we have a central point where the data is being stored and each client is accessing the same data through that central point. So this is a typical database architecture, that the database is stored at a central point and each client is just accessing the data from that database. Now, if we see the architecture for blockchain, you see that we have different nodes connected to each other. These nodes are nothing but computers which are connected to each other, and each computer has the same database. So it's not like we have a central point where the whole data is being stored. Each computer has their set of database maintained, and this database is synchronized within the whole process. So node A to E, each node is going to have the same database. If some new data is entered by any of the node, then each of the node will update the database which is stored with them. So this is how the architecture of blockchain is actually different from the architecture of database. Now, if you look at the architecture of database, what is the problem with that architecture? The first problem is that there is a single point of failure. If our database goes down, then our whole system will go down. Although in the current architectures under the applications, we employ a phenomena of replications where we store the different databases as a replicas of the current database. But the thing is that these databases also have some kind of cost associated for us. We have to set up the servers, we have to set up the database software. So there is a cost associated with that. Moreover, this database has the phenomenon phenomena of administrator privileges. So there is a single user who has the complete control of this database and who can easily modify or delete the data within this database. Then we also have the concerns related to security issues, because we have different kinds of issues. A typical issue is that normally system administrators set up the database as the default username and password, which is one of the major issues. Then there could be an issue related to SQL injection. There could also be an issue related to some other kind of SQL attacks which might happen on the database. And finally, there is no transparency of the data. It's more of like each person has their own view of the database. So each client will only see the data which they have access to. So we don't have the transparency maintained with the database. Now coming to the blockchain, what are the advantages of the blockchain over the traditional database? The first thing is decentralization or distribution, because now every computer has their own database maintained with them. There is no central point of database. Everyone has their own database. So in turn, what we are doing is that we are maintaining the redundant databases with the different computers itself. The second thing is immutability. If somehow somebody tries to change any data within the blockchain, then what is going to happen? The other nodes can easily verify that this data was not supposed to happen and this should not be modified, and they can easily find the culprit and remove them from the system. Then we have transparency, because each node or each computer has their own set of database stored with them. So they have the transparency to see that what is being stored within that database. Then we also have security, because we are using the feature sets of cryptography. Whatever data is being stored on top of the blockchain is being encrypted using some kind of cryptography algorithms. And finally, we are removing the intermediaries which are present with the databases. So we have removed the central point, we have removed the intermediary as a central database, and we are making sure that this is more of like a distributed nature or a democratic nature which is present with our system. So those are some of the advantages of blockchain over the traditional database. It's not like we are trying to replace the traditional database with blockchain, but the feature is more of that blockchain can easily build upon the traditional database. It's more of like we are helping the traditional database to achieve new heights. Now coming to some of the differences between blockchain and database. The first important difference, if you notice with the architecture, is the authority of the database. Blockchain is basically decentralized or distributed, but database is typically centralized because we have only one system which is storing the data. Moreover, blockchain has a distributed architecture, but the traditional databases follows a client-server architecture. Within the database, we have permitted all the operations. The users can create, read, update, or delete any kind of data. Within the blockchain, we only have the operations for read and write. So nobody can delete or update the data. Then we also have integrity maintained with blockchain because nobody can change the data, but with database alterations are allowed. You can easily update the data. Transparency for the blockchain is built in. With database, it's not transparent, although you can make sure that your database is transparent, but this is not a built-in functionality with the database. Finally, the trust system with the database, the owner of the database is the trusted party, and we are trusting the owner to make sure that our data is secure. But with the blockchain, we are trusting the system, the algorithms which are actually forming the blockchain. So these are some of the different advantages of blockchain over the database. And these advantages help us to achieve new use cases which were not present with the traditional database. There are many different applications which we are employing in the current world which are using blockchain to achieve the same. Now we have understood the process of what blockchain is and how it is different from databases. Now let's go and understand the role of intermediaries in our traditional systems. So intermediaries are present in our day-to-day life. What kind of service you are performing, you will have some kind of intermediary in between. Let's say you are using internet. So the trustful communication which is carried out within the internet, for let's say you are talking to google.com. So you are going into your browser, writing google.com, and then you are communicating. The trust or the security which is established between you and the google.com server is done through a certificate authority, which is an intermediary for you. If you take the real world examples, if you go and do some kind of transactions, then we have banks in between, which act as intermediaries. If we talk about a football match, then there are referees, which are going to act as intermediaries. So intermediaries are present everywhere for different kind of jobs which we are doing. The problem with the intermediaries is that we are dependent upon them. So it could be a possibility that these intermediaries are not safeguarded. These intermediaries are corrupt and they want to take the advantage of such a situation. So blockchain is actually removing those intermediaries and building the trust within the system. So what are the function of intermediaries? Let's first understand the function of intermediaries, how they are present under our different use cases, and then we will see that how blockchain is removing them. So the function of intermediaries. The major function of intermediaries are related to information gathering. So they will gather the information, collect the information, and sell that information to different parties. They also help in the promotion of different services. For example, you have intermediaries related to social media marketing, where they are promoting your goods or your products. Then you also have the function of contacts. So intermediaries are the people who have different contacts established, and they will help you to understand the whole scenario and get those feature sets to you. For example, if you are dealing with the travel agency, so they have the contacts related to the airlines, the hotels, and different other services. So they will create a package for you and then deliver the same. They also have the negotiation function. Negotiation is basically they will negotiate on your behalf with the different services. Again, going to the travel industry, they will be negotiating with the hotels or the airlines. They have physical distribution too. Physical distribution is mainly related to how they are distributing the products. So it could be that intermediaries are present within the supply chain, where they are taking the products from the manufacturer and distributing them to the wholesaler or retailers. They also manage the financing. So something like banks who act as intermediaries in between, and then they help us to manage our finances. Then they also provide the risk analysis on the different activities which are performed with us. So intermediaries, if you see the total functions of intermediaries, you will realize that they are present everywhere. What kind of service we are doing? We are actually dealing with intermediary. If you are using an email service, then you might have intermediaries like Microsoft and Google. If you are dealing with cloud storage, you have intermediaries like Amazon or Microsoft. So everywhere we have some kind of intermediaries available within the system. Now, this is just an example of the role of intermediaries under tourism industry. If you see here, we have defined upstream and downstream. In the upstream end, we have the different products and services which are provided by the manufacturers. So you have food and drink manufacturers, equipment manufacturers. You have some kind of waste recycling, furniture manufacturers, water energy supplies, craft products. Then in between the midstream, you have the services which are using these manufacturers. So something like theme parks are there, natural or historical or some kind of sports attractions are there who are using these kind of services. You have hotels which might have some kind of food and drink manufacturers with them. Bars and restaurants are there, transport is there, shopping centers is there, handicraft shops are there. So there are different midstream services who are actually utilizing the upstream services and getting their products. Now the major problem arises is the downstream end, where you have all these tour operators. These tour operators under tourism industry, they will actually contact the midstream and the upstream services and create tour packages for you, which they will sell it across to the retail market or the tourist customers. Now the major problem with these intermediaries here, that they have different level of packages created for you. They can negotiate at a very low cost with the midstream and upstream and sell you with a very high cost. For example, I'll just give you one example. Let's say there is a concert happening, a musical concert happening, and there is an intermediary service present who is selling off those musical concert tickets. Now, the problem with such a musical concert is that if we have a third party and if they are selling the tickets, then what they will mostly do that by the end of the closing or by the end of the closing of the tickets, they will increase the prices. If they have some kind of second tickets left, or you can say the tickets which are safeguarded for some kind of VIP service, they will charge very heavy for those tickets. It also a problem that people also take advantage of that. Within the concert situation, it could be a possible that you have not acquired the concert ticket and you are buying it from some other person, and he might even charge you double the price for the same. So there are different kind of things which are happening through these intermediaries. Inside our tourism example also, the tour operators are actually charging very heavy for all these services which are present here. Moreover, we are dependent upon our tour operators and travel agents to make sure that our whole package is defined, and then only we will buy it from them. But what if we take this whole scenario to blockchain? What if we completely remove the tour operators and travel agents in between? So what's going to happen? That the midstream and upstream then can directly sell it across to the retail markets and tourist customers. For example, that a hotel is costing $4,000. Then the tour operators are charging something like $8,000 for that. So they are charging almost double the price. And you are purchasing it from the tour operators, and they are just getting some kind of advantage from the same. But if we directly take this to a blockchain kind of scenario, then we will remove these intermediaries. So both the parties, the midstream and the downstream parties, will be benefited by this. Even if the midstream charges at something like $6,000, it's again cheaper for you. Moreover, midstream are also getting much more better price for their services which they are being offered. So we are removing the middleman in between. We are completely removing the intermediaries, and we are making sure that these kind of things are happening on the blockchain. So let's say if you buy a ticket for a theme park, that will be permanently stored over the blockchain. So nobody can take your ticket out. Nobody can forge your ticket. You cannot take your ticket out from blockchain and resell it as per your needs, because there is only one means of communication for the same. And that's how the blockchain is actually removing the intermediaries for our whole scenario. So till now we have been talking about blockchain, but we have only covered the general concepts of blockchain. We have not got into details of what actually constitutes the blockchain and how blockchain is being formed. But before we discuss about how blockchain is formed and what are the different important concepts under blockchain, let's talk about the cryptography. We have been telling that cryptography is the major thing behind blockchain, which helps us to secure the system. And also people are going to trust this cryptography, which is built inherently with the blockchain. So what kind of cryptography is used with the blockchain? Under cryptography, let's first understand what actually cryptography is. Whenever we talk about cryptography, we only talk about securing the information. Basically, what cryptography is a technique which helps us to hide the information. Normally, how we function is that we take the whole internet domain as an open domain. Whatever we are communicating, whatever we are sending in this internet domain has to be protected, because there could be a third person who is trying to read our data or acting as a man in the middle and trying to take over the services which we are performing. The major thing is that let's say you have a laptop. You are not connected to internet. If you store any kind of data on your laptop, which is not even secure, even if you don't use any cryptography and have not provided any kind of encryption, but you are not connected to any kind of internet services, you don't have any communication enabled. Until and unless your laptop is physically stolen, your data is safe with you. Now the concept arises once you connect to the internet. Once you connect to the internet, you have established a communication process with different computers throughout the world. What is the internet? Internet is basically a combination of different LAN networks combined together, who forms a kind of a channel for each computer to communicate with each other. That's what internet is. And cryptography is one of the technique which helps us to safeguard what we are trying to share across throughout the internet. So if you see the example here, you can see there is a spy and there is an MI6 agent, and this spy wants to send some plain text to the MI6 agent. He is taking this plain text. He has put up a password within the encrypt function. The output for encrypt function is a ciphertext, which is sent across within the insecure transmission, that is the internet itself. And this ciphertext is received by the MI6 agent, who uses the same password to decrypt back the plain text, just to make sure that the information which is being shared is in a hidden format. Now, this cryptography is typically defined into two different types. The first one is a symmetric cryptography, which is also known as private key cryptography. Whenever we talk about symmetric cryptography, we are only talking about one single key. So the person who is sending the data and the person who is receiving the data, both are using the same cryptographic key. The second type of cryptography, which is typically used behind blockchain, is asymmetric cryptography, which is also known as public key cryptography. So whenever we have asymmetric cryptography, we talk always about two keys. One is a private key, the other one is a public key. Private key is something which has to be securely safeguarded with you, and public key is something which you can distribute to everyone inside your scenario. This is a one-way function. You can generate the public key out of the private key, but vice versa is not possible under such scenario. That's why we can distribute the public key to everyone within our use cases. So coming to the actual working of these cryptography, if you see the example here, this is the example for symmetric cryptography. We have two people, Alice and Bob, who wants to communicate with each other. So Alice has a message M. Alice is computing the ciphertext for message M by using a symmetric key, which is known as K, and then send it to the Bob. The ciphertext here is known as C. Bob is receiving the C. Bob is computing the decryption function using the same key K and then getting the original message out. So symmetric cryptography using the same key for encryption and decryption. On the other hand, with asymmetric cryptography, we always have two keys. So whenever you are sending any kind of data, you can use the public key to encrypt it, and the other person can use his private key to decrypt it. Basically, the process is that if you are using the public key of the person to encrypt the data, you are making sure that this is the only person who will be able to decrypt the data, because he's the only person who has the private key. Nobody else has the private key. And this is the kind of cryptography which we use behind blockchain. Whenever you go and create an account with blockchain, this is also known as blockchain wallets. So whenever you create an account, you generate two different kind of things. One is known as the private key and the other one is known as a blockchain address. So private key is like a signature under a bank account. Whenever you are sending any kind of data to any other person, you have to sign that data or you have to sign that transaction. Same is the case with the banks, that once you want to make any transaction, you have to sign it. You have to provide your signature that it's you who is making the transaction. And that's what private keys are used in the blockchain also. If you are sending any data, you sign it using the private key. Now, if somebody wants to send any data to you, they are going to use your public addresses. In terms, public address is basically the public key of the cryptography. Blockchain employs some other mathematical computations to generate the public key, but this is generated from the public key itself. So the address under blockchain is always generated from the public key itself. So if somebody wants to send any kind of cryptocurrency to you or any kind of data to you, they will use your public address to send it across and you can access it using your private key. If you are sending to somebody, then you can use your private key to send the data to the other person. So this is the cryptography which we use behind blockchain. The second concept which is important under blockchain is hashing. What is a hashing? Hashing is a function which converts a variable length of data into a fixed length. It doesn't matter what is the input of the data, the output is always going to be the same. For example, if I talk about one of the algorithms like SHA-256, even if you input 1 byte of data or you input 1 terabyte of data, the output will always be 256 bit. That's the major function of hashing. This is a one-way function and it's kind of a function that even if single bit of information is changed, the hash of the function will be different. And that's why we use hashing under blockchain, to make sure that nobody is able to modify the data. So whatever type of data we are uploading on top of blockchain, let's say you are sending some money to me, then what is going to happen? Your transaction will be hashed and then stored on top of the blockchain. Because if somebody tries to take your transaction out or change it, then your hash will be different and both the hashes will not match, and it will make sure that our blockchain is secure. So hashing algorithm is also one of the major concepts which we use behind blockchain. The third important concept which is actually linked with hashing is known as Merkle trees. What are Merkle trees under blockchain? You know the concept that we have a layer of blockchain built up. So you have the blockchain. Blockchain is built using blocks which are interconnected to each other. And inside the blocks, you always have the transaction. The process is that once a block is created, it is sent to a verifier. Typically in Bitcoin, they are known as miners, and they do some kind of mathematical computation on top of these blocks to verify them and put up over the blockchain. Now the problem arises that a block could have multiple transactions under this. Now if a miner or verifier verifies all these transactions, it doesn't make sense for us because he will be taking a lot more time to verify all the transactions under a single block. So what we do that instead of storing all the transactions directly, we create a Merkle tree under that block. What is a Merkle tree? Merkle tree under blockchain is basically the hashing of all the transactions together. Let's say my Merkle tree, my block, single block has 4 transactions, A, B, C, D. So what is going to happen? We are going to take the hash of transaction A. We will go and take the transaction B, take the hash of transaction C, take the hash of transaction D. Then we will combine these two hashes together to form the hash of AB. Similarly, combine these together to form the hash of CD. Then again, we will take the hash of these two together, combine them together to form a one single hash. So it's more of like a bottom to top approach for a binary tree where we are just taking the hashes, combining them together, taking the hashes, combining them together until and unless we found one single root hash here. Now, why we require this root hash? Why Merkle trees are required under blockchain? Now, if a miner wants to verify all the transactions under the blockchain, he only has to look onto this top hash. Because the thing is, this top hash is actually formed from all the different hashes for transaction. So if transaction A changes, this top hash will be different. B changes, this top hash will be different. Similarly, C or D changes, this top hash will be different. So the miner or the verifier don't need to go and see all the transactions. He can just directly see the top hash and be sure that all the transactions are verified under the blockchain. So that's the third important cryptography technique which is required for blockchain. So now we have understood the different concepts with blockchain, and we have seen that how blockchain is providing different advantages related to the traditional technologies. Now let's go ahead and see that how a typical blockchain solution looks like. For understanding how blockchain solution works, let's take an example. Let's take a group of 5 people who are situated in one single room. And they decide that they want to create their own currency. They want to form their own currency and they want to transact everything using their own currency. Now, within this group of people, they also want a situation where they can track the flow of funds, that who is sending the transaction to whom. So what did they do? They appoint one single person within their situation. This person, for our example, is known as Bill, who is appointed for the tracking of flow of funds. So whenever any transaction occurs, Bill is noting down the transaction within his notebook. So if Rob sends some money to Mike, then this is noted down in the notebook. If Mike is sending something to Tom, this is noted down inside the notebook. If Andy is something sent to Bill, then this is also noted down in the notebook. Now there are 2 possible scenarios in which this kind of situation will not work. The first scenario is that we have created a trusted central party who is noting down all the transactions. So our first scenario is that this trusted central party might be corrupt. The second central scenario for our solution where the problem may arise is that the other 4 who are present inside our scenario might be an attacker who wants to hack the system and modify the transactions within this system. So 2 different scenarios present with us. One, the person who is holding the notebook might be corrupt, and the second scenario, the second person who is under our complete environment might also try to hack the system. So let's take both the examples to analyze this. So let's take the first example, that if the person known as Bill is a malign person and tries to change our notebook itself. So as a central authority who is part of our solution, Bill is easily able to change all those transactions. Soon, Rob, Mike, Andy, and Tom realized that this is not a good solution because only one person is keeping the notebook. So they decided that, okay, now instead of one person keeping the notebook, we can share this notebook with everyone. So everyone is going to note down the transaction. So if Rob sends anybody to Mike, then Bill, Andy, Tom, Mike, Rob, all five will note down the transaction. If Mike sends something to Tom, similarly, everybody is going to note down the transaction. So this is one of the situation which we created, that everybody is holding the same kind of data. And then if somebody tries to modify anything in the data, the other four can easily verify that this is not supposed to happen. This is not the correct entry. And this is a malign person who is trying to change the entries in our notebook. So this is how the blockchain also works, that we have distributed the data throughout the different computers. If somebody tries to modify the data, the other computers can verify that this was not supposed to happen. So this is only the first scenario where we are taking that the person who is holding the data might want to change some kind of data within that notebook. Now coming to the second person, I'll just open a brief window here to explain that. The second person, let's say Bill is noting down all the transactions. So he has first transaction, Andy sends 1 coin to Bill. Then he has second transaction, Bill sends 5 coins to Tom. And similarly, he can go ahead and have other transactions related to the personals here. So he can have Rob sends 2 coins to Bill. Now let's take a scenario that this is the current notebook which we are dealing with. Our first scenario is safeguarded only by distributing the notebook with different persons. So now coming to our second scenario, which is also a problem for us, that let's say Bill is holding this notebook and Bill has all these transactions. For now, we are saying that Bill is the party to make sure that these transactions are secure, and we can have another party, let's call him as Rob, is the attacker who wants to benefit from the system. So now what happened, that they have created this whole notebook. They are noting down all the transactions. Bill is noting down all the transactions. The problem arises that it could be a possibility that everyone is sleeping in the night and Rob tried to change something in this. Rob wants to change this transaction where he's sending some coins to Bill. So instead of this, Rob altered the transactions in the night, and he might change this to something like this, that all the transactions are present, but he only went ahead and modified his transaction from 2 coins to 1 coin. So this is a possible scenario where an external hacker might try to change the central system. Now this is again a not good solution for us. So for now, Bill in the morning realizes that there is someone inside our scenario who is trying to change the transaction and get benefit for it. So what Bill decided, that instead of storing these transactions as such, what I'm going to do, I'm going to actually interlink these transactions. So what he's going to do, that the first transaction is this one, Andy sends 1 coin to Bill. The second transaction is actually combination of these two. So both of these two are interlinked to each other. So he will have this and this. The third transaction is again a combination of all the previous transactions. So he created a linking of all the transactions that nobody is able to figure out such a solution. But this person, Rob, is a very good attacker and he wants to gain some kind of benefit from the solution. So what he did, again one night they went to sleep, he took the notebook and he figured out that Bill is actually keeping all the transactions as such. So what he did, he went ahead and modified all these transactions till the point to his own transactions, and then he came to this solution where he just replaced this to 1 coin. So he replaces every transaction again inside this. Again, the Bill was not satisfied with such a solution. He was not able to figure out that how the person is able to still modify this. So what he decided, he created a new thing what he did, that he took the transactions and he started using a hash function. As I told you before, hash function is a one-way function which converts the variable length of data into a fixed length. So whatever input I am sending to the hash function, the output is always fixed. For example, SHA-256, the output is always 256 bit. If you pass 1 byte of data or 1 gigabyte of data, the output is always fixed. So he started using the hash function. So what he did, that he took this first transaction and he sends 1 coin to Bill. Then he took the hash of the transaction with this. So pass it to a SHA-256 function just for an example and pass this same transaction here, and he sends 1 coin to Bill. So he took the hash. Instead of putting up the transaction, he started taking the hash. Now the second one here, what he did, that now he started joining all the hashes of the transaction instead of the transaction itself. So he started taking the whole concept, this one, the transaction with the hash. He took this, place it here. Then he came to the second transaction, and also with this he took the SHA-256 of the second transaction. So he created this kind of concept for all the transactions he has inside the system. So take this one, do the SHA-256 of this. So this, and here the addition is basically this plus SHA-256 of the second transaction. So Bill sends 5 coins to Tom. So he started doing the hash of the functions. Instead of directly taking the transaction, all the hashes are added together. So here also he started creating the hash of this. So, and he sends 1 coin to Bill. Then he will have the hash here also. And the same will continue for all the other transactions which are part of the system. So every transaction is now included with the hashing function. But this Rob is actually a very good attacker, and he figured out this hashing function. He figured out that Bill is actually using a hashing function, and this is not a good solution for Bill also. So what he did, he again on one night figured out everything, and he modified all the hashes at his end, replaced all the hashes and changed his final transaction to his own benefit. So again, this was not a good solution, because the person who is not Bill is able to modify the transactions by figuring out the algorithms. Now to make it harder, what Bill did, that instead of just adding a hash of a transaction, Bill started adding a random number with this transaction. So he added something like 789. So here the hash will be formed, which will be something like an alphanumeric string. So again, came to the second one, he started using this alphanumeric string. Then with this, he added the hash of the second one. So he added again a random number here, something like 567. So he keep on adding all these random numbers to make sure that these hashes are randomized and the attacker is not able to figure out. But he created this whole scenario in a way that he is able to figure out the hashes. So he added the hashes in a way that whenever he create the hash of a transaction, the final digits, or the, you can say the early digits here, the starting 2 digits are basically starting with 00. So whenever he creates a hash, the digits should be ending up with 00. So if he creates the hash of this one, so his final output will be something from 00 and then the alphanumeric string. So he started adding the hashes in such a way to make it much more complicated. And now the problem arises for an attacker, because this is a random number added by the person who is trying to secure this whole communication, and he has made the whole concept very complex. So the attacker is not able to figure it out. Soon Bill realized that this notebook, if he only keeps the notebook, then again it's a problem that people might doubt him that he's using all this situation. So he distributed the notebook to everyone, and that's the whole concept of blockchain now. The blockchain also works in the pretty much similar concept. We have the transactions, like these transactions are there. We take the hash of these transactions by adding a nonce variable with the transaction. These transactions, you can directly link it with the block itself. So these are the different blocks which are part of the blockchain, and there is a nonce variable added this way. This nonce variable is chosen in a certain way where you have certain leading zeros inside the hash of the block, and each block hash is joined with the second block. So we keep on forming the whole chain, and thus the blockchain keeps on originating. Once we take this kind of solution, distribute it to everyone, and that's the complete blockchain. You will get a much more clear view about this whole scenario, but this is how the blockchain is actually solving the current problem related to that we only have a central party who is controlling the system, or there could be another person who might try to attack the system and take advantage of our system. So that's how the blockchain is basically solving this. If we go back to our slides here, you will notice that now how blockchain works. If you look back to our example, all the transactions which are put up by the bill, you can take them as blocks. These blocks are basically hashed together in a form of a chain, and these are distributed to every other computer in the world. And that's how the whole blockchain works, that each node or each computer is holding the same data, and the transactions are basically recorded in a cryptographic format, and everything is joined to each other. And that's how the whole blockchain came into being. Once a node receives the transaction, what they do is that they verify whether the transactions are correct or not. They put up an electronic vote, which is also known as a consensus mechanism, to verify whether everything is working fine or not. If everything is working fine, then they will just make sure that this transaction is uploaded to the blockchain. Normally, in the case of Bitcoin, it's more of like 2 by 3 of the total computers agree on the transaction, and this will be updated on each computer. And that's how the whole blockchain works. So summarizing, the example here, which you see here, is basically how the blockchain works. Each person who is sharing the transactions or keeping the notebook with them are acting as nodes or computers. In the Bitcoin, it's more of like a new block of information is formed in every 10 minutes. So all the transactions are put up inside a block. Then the hash of block is taken, and this hash of block is incorporated with the next block. And thus the registry is updated for the whole blockchain. And that's how the blockchain works. So now you have understood the different concepts regarding blockchain. Now let's try to link all these concepts together so to get a clear understanding of how blockchain actually functions. So you have seen that how the immutability is maintained. You have seen that we have talked about blocks, transactions, and Merkle trees. Let's just go into deep about all these concepts and understand that how the actual blockchain functions. So the first important thing with the blockchain, which we have already discussed, is the private key which is required for interacting with blockchain. Whenever you create an account with the blockchain, you will always get two things. The first thing is your private key, and the second one is your public address. Private key is basically like a signature for each transaction over blockchain. So you are sending a transaction, you will sign it using your private key. On the other hand, the public address is basically something like an account number for you. So if somebody is sending you a transaction, he will be using your public address to send the transaction to you. An example of the private key is shown here on the screen. You can see this is an alphanumeric string generated from a cryptographic algorithm. Normally, the ECC algorithm is used for generating the private key here. The second thing important with blockchain are the addresses. The public addresses which we have talked about are the core representation of the public key itself. It's a one-way hash function which is used to derive the address from the public key. Normally we use a secure hash algorithm like SHA-256, or it could also be based upon another algorithm which is known as Race Integrity Primitives Evaluation Message Digest. So these two algorithms are normally employed for creating the public addresses. You can see an example of public address over the screen. Again, it's an alphanumeric string generated here, and this is a one-way function generated from the public key. Apart from this, we have also discussed the concept about transaction. Whenever you are sending any data, whenever you are sending any cryptocurrency to any person in the world over a blockchain, you are basically creating a transaction. Transactions are the records of data on top of the blockchain. Each transaction record is stored in a chronological order, and as we have already discussed, transactions are actually grouped inside a Merkle tree to make sure that the verification process is much simpler within the blockchain. The transactions which are primarily submitted on the blockchain are initially connected to a pool which is known as unconfirmed transactions. What is an unconfirmed transaction? Unconfirmed transaction is basically saying that these transactions are not yet achieved consensus. So other nodes, other computers have not verified that this is a confirmed transaction. So whenever you create a new transaction, this is going to go inside an unconfirmed transaction pool. The miners actually work on these unconfirmed transactions. They will take out the unconfirmed transactions from the pool. Then they will include these transactions inside a block. They will form a block. They will take the hash of the block and then they will solve a mathematical puzzle to get the actual block hash and then solve and store the block on top of the blockchain. Whenever I say a mathematical puzzle, this is basically the calculation of nonce value. If you remember, when we talked about how blockchain works, we discussed that the person is trying to attach a random number with the transactions to make sure there is some kind of randomization available within the whole process. That's the thing, that's the nonce value which the miners are trying to guess and get the hash value. And once the miners are able to get this hash value, then they are able to confirm the block over the blockchain. Miners normally take these transactions out of the pool, verify them, put those transactions inside the block. Then the block is being formed. Then they try to guess the nonce value to generate the hash of the block and then put this block over the blockchain. Whenever a next block opens up, it will take the previous block hash, again take the transactions out of the memory pool. Again, the whole process continuously repeats. So that's the main part about transactions. Transactions, apart from the normal information, also store some kind of metadata information which might be utilized to store some additional data on top of the blockchain. If you see the diagram here, you can see a basic representation of transactions here. So you see that whenever you have a transaction is basically built up using the public key. When we say a public key, this is basically the public address. So whenever you are specifying a transaction, you are going to send it across to somebody else. Suppose I am sending you a data, I will create a transaction. So I am going to use your public address to send it across to you. So I am going to take your public address, which in turn is your public key, and then I am going to generate the signature out of it and then send it across to you. And on your end, you can verify that using your private key. So that's the main part about this, that how you want to send across this. Similarly, if I am sending you a transaction, I am signing it with my private key, and you can easily get that using my public key or my public address. So it works in both the fashion. This is a basic example of transactions which is used behind the Bitcoin. After that, we have the concept of blocks. So once you create the transactions, what happens is that these transactions are put up inside a block. What is a block? Block is just a blob of data. You can say it as a container of data structure which contains some of the confirmed transaction. Whenever we have a block, there are different things which are part of the block. There is a block header which is defined to identify the block, and then there are the actual transactions which are part of the block. Whenever a block is being formed, this block is confirmed over the blockchain by miners. So miners is the main entity who is actually forming the blocks and then confirming the block over the blockchain. Within the Bitcoin algorithm, there is a protocol that for every 10 minutes, a new block has to be formed. If the blockchain is going above 10 minutes, then the difficulty of blockchain is reduced. If the blockchain is going below 10 minutes, then the difficulty of blockchain is increased. You will see that why this 10 minutes concept is important when we discuss about the consensus algorithm. So basically, once everything is done, once you take the transactions out of the memory pool, put up inside the block, then you form the Merkle tree, also add that inside the block, then the miners try to guess the nonce value, solve the same situation, and then finally get the output from there. So once everything is done, once the miners has confirmed the block over the blockchain, now the block is going to be distributed to different other people, and those people are going to provide consensus over it. So consensus is basically providing voting over it. So we will see that how consensus works and how the finality of the transaction is maintained with that. Whenever we discuss about blocks, there are three major things inside block. The first one is a block header. The second one is a block identifier. And the third one is the Merkle tree. What is a block header here? Block header is basically a collection of information which showcase that what different things could be part of the block. So here the block header is defined as the hash of the previous block. It could be some other metadata. It could also be a Merkle root. All these things will be part of the block header. Apart from that, you will have the Merkle root. Merkle root is basically the hash of all the transactions combined, which is directly utilized by the miners or verifiers to make sure that each transaction is working fine within the blockchain. So that's the main concept of block here. You can see in the diagram here that we have transactions where the Merkle root is taken and the blocks are joined together as the hash of the previous block is taken into the next block. This is an example of a Bitcoin block. You can see the various information which are present within the Bitcoin block. There is a magic number which always defines that whether you are using a mainnet or a testnet. Then there is a block size which defines the number of bytes for the block. Then there is a block header which has 6 different items. We will discuss that. Then there is a transaction counter and the total transactions which are present within the block. So I'll just give you a brief example here to visualize this. Let's just open this. So what is happening? Let's say we have 2 users. We have many users. Let's say Alice, Bob, Eve, Dave. There are many users present inside our system, and these people are sending transactions to each other within the blockchain. So first transaction comes in that Alice sends 1 coin to Bob. Then second comes in, Bob sends 1 coin to Eve. Then third comes in, Dave sends 7 coins to Alice. So all these transactions are coming in. What is happening once these transactions are coming in? These are going inside a unconfirmed transaction pool. So all the transactions are going to be part of an unconfirmed transaction pool. What is an unconfirmed transaction pool? This is a pool shared by everyone. So Alice, Bob, Eve, Dave have the similar pool where the transactions are put up which are not yet verified. So all the transactions, you can have a third transaction. Eve sends 2 coins to Dave. Then all the other transactions from here, that Bob sends 5 coins to Dave. So all the transactions which people are doing are coming into the unconfirmed transaction pool. Now the concept comes in that we have an entity which is known as miners. So what a miner will do here, the first step miner will do here, miner will start forming a block. So what this block is going to be about, what miner is going to do here, he is going to create a block here. This block will have the information whether this block is part of mainnet or testnet. So either you are going into the main chain or you are going into the test chain. So this information will be there. Then this information will also have something like Merkle root. It will have some other information like block header. Normally when we say block header, there are multiple information inside a block header. There is something known as block height here. There is also the previous block hash here, and some other information is also included with the block header. So they will have the mainnet, the testnet, they will have the block header which says block height, previous block hash. Block height is basically the length of the block. If I say the block height is 100, that means there are 99 blocks behind it. If I say it's 200, that means there are 199 blocks behind it. So block height, previous block hash, and all the other metadata information are present with the block header. It will also have information like size of the block and some other information. Now after this you have Merkle root, and the final thing they have the transactions itself. And there is one important also thing present here which is known as transaction counter. So they start creating the block. They put up that this is block going to be part of mainnet. They create the block height. They take the previous block hash and calculate the size of the block. How the size of the block is calculated? Size of the block is basically calculated by taking up the transaction. So let's say initially miner takes out these 2 transactions out of unconfirmed pool and then put up these 2 transactions under the block. So 2 important things. The first one is this one, which is above this, and the second one are the actual transactions. Once he put up these two transactions here, what is happening? We start forming the Merkle root. We take the hash of this transaction, we take the hash of this transaction, we combine these two transaction hashes together, and we form a Merkle root here. Then our transaction counter also says the value is 2. Block height is as per the length of the block. Previous block hash is the previous block which has been confirmed. Size of the block is basically the transaction size itself. And then we are going to put up this block at the mainnet. So these are the different things which miners compute. Once miner confirm that this block has been formed, what happens is, as you remember when we were discussing about how blockchain works, we came to a system that once a block has been formed, then what we have to do, we have to take the hash of the block. But here we want to make sure that this hash is of a certain randomization. So what we do is that we add a nonce value with this. This nonce value, which is defined here, this nonce value is actually defined by the blockchain algorithm. So this nonce value is typically related to the blockchain difficulty. That what is going to be the difficulty for this blockchain. So you define the nonce value as such. Normally this nonce value is of very large size. For example, in Bitcoin, this nonce value is up to 2 to the power 67, which is very huge. So miners know the block. Miners need to calculate the hash of the block, but they don't know the nonce value. But there is a limitation here that the blockchain defines. The hash of the block should always have 2 leading zeros. For now, I'm just taking an example that the hash of the block has to be generated. The nonce value has to be put up in a way that the hash of the block has 2 leading zeros. It could be something like 10 leading zeros also. So you have to generate the hash which has 10 leading zeros. So miner forms this whole block. He knows this information, the whole block he has created at himself. Now he starts guessing this nonce value. He starts calculated. He starts from 0, keep on increasing this nonce value till the point the hash of the block comes out to be 10 leading zeros. That's the main concept of miners. And that's why the Bitcoin miners take a lot more energy, because what they are doing, they are actually running a counter to increase this nonce value and keep on calculating the different hashes till the point they reach at such a position where the hash of the block has 10 leading zeros. And these 10 leading zeros are defined by the blockchain difficulty. So what a blockchain works on? Blockchain works on a rule that it has to follow the 10 minutes mark. We will discuss that why 10 minutes is important. But if this 10 minutes is not being followed, they will increase or decrease the difficulty as such. And thus the hash of the block will also increase and decrease according to that. So that's the main concept about blockchain, that how from the transaction we end up to a block. So this is the first block which is being formed. After this has been confirmed, miner will announce it that I have found out that I have generated the hash of the block which has 10 leading zeros. So I have solved the value for nonce. Now this block can be put up on the blockchain. Once he does that, then we come into the process of consensus algorithm. We will also discuss about consensus algorithm in this course. So that's the main concept which happens with the blockchain. Coming back to our slides now. So these are some of the informations which are present with the Bitcoin block. Now, the concept of Merkle tree we have already discussed. You can see the example here that we have transaction A, B, C, D. Take the hash of A, take the hash of B, join them together, C, D, join them together, and finally join these two together and take the hash, which is basically the root hash or the Merkle root hash, which will be put up with the block. So that's the main concept for the Merkle tree. Within the blockchain, the Merkle tree works in this fashion, which I already discussed on the notepad there. So you have the concept that you are taking the hash of transaction 1, 2, computing this, taking the hash of transaction 3, 4, computing this, and then you are filling up the block. And each block is joined together with the block hashes. So once you solve for the block hash, you join it in the next block. So you add the block hash in the header of the next block. And that's how the whole blockchain is being formed here. So now we have understood the typical concepts of blockchain. We have seen that how blockchain functions, and we have also seen the various parts which are behind blockchain. So I have given you a very brief concept of how transactions are put up with the blockchain, and then how transactions are included inside the block, and then the block is being confirmed over the blockchain. Now, once the block is confirmed over the blockchain, then there is another fundamental which comes into play known as consensus mechanism. Consensus mechanism is a process where all the parties inside the blockchain agrees that this is the correct block, and then they put up this block on top of their copy of the blockchain which they're holding at their own laptops. So that's the main part about consensus mechanism. But this consensus mechanism is very complex. Let's try to dive down inside consensus mechanism and see that how the actual consensus mechanism is formed. So what is a consensus? Consensus under blockchain is the process where different participants who are acting or dependent upon the incentives, and they do some kind of work to make sure that the block is being confirmed over the blockchain. Whenever a new block gets broadcasted on the network, the nodes connected to the network have the option either to include that block in their copy of ledger or to ignore that. When majority of the nodes which are comprising of the network decide that this block can be included inside our blockchain, then the consensus is achieved. But why this consensus came into being? Let's understand from a point of a problem which is known as two generals problem to understand this consensus better. So two generals problem. Two generals problem is a non-solvable problem. What does this problem states? This problem states that there is an enemy camp located over a hill or over a mountain, and there are two generals of the same army which are located at the opposite end of the hill. So general 1 is on the one side, general 2 is on the other side, and the enemy camp is just in the middle of the whole process. Now these two generals wants to make sure that they attack the enemy camp together. But the problem is they don't have a communication enabled. If they want to send a messenger across, this messenger has to actually go through the enemy camp and then give the information to the general 2. So that's the main process behind our two generals problem, because they cannot attack the enemy camp in single-handedly. They have to allocate a time and make sure that these two generals are attacking together to make sure that they are winning the war. Now this problem has a very kind of like a good problem, because this thing is actually our internet system. So if you take this example again, if the general 1 wants to send a message to the general 2 through a messenger, it could be a possibility that enemy camp, here the messenger can be intercepted, he will be modified, or the messenger could be replaced by their own messenger, and they will tell a fake time to general 2, and both the generals will not be able to attack at the same time. And this is a continuous problem. If general 2 wants to provide an acknowledgement, he will send across from here, then again the enemy camp will modify this and send to general 1. Let's say general 1 here is saying that we are going to attack at dawn. Now here the enemy camp modified it that we are attacking in morning. General 2 sends back the message that we are attacking in morning. Enemy camp again takes the messenger, modifies the message that we are attacking at dawn. So here the general 1 is thinking that we are attacking at dawn. General 2 is thinking that we are attacking in morning, and both will be never able to agree on such a situation. So this is a non-solvable problem which is existing in our internet, that we are not able to make sure that our data is securely transmitted from one computer to another computer, because the whole internet is taken as an enemy camp. Now, taking from this two generals problem, there is another problem which is defined, which is known as a generalized general problems, or it's more of like a Byzantine generals problem. Now, instead of these two generals, let's take a scenario where are multiple generals part of the system. Let's say 100 generals are part of the system, and these 100 generals need to agree on a common time to attack over the enemy. If they are not able to attack over the common time, then they won't be able to successfully win the war. But in this problem, we take that out of these 100 generals, there is one single general who is basically a malign person who doesn't want this attack to succeed. So what he's trying to do, he's trying to modify the time which is shared between all these generals. So this is a Byzantine generals problem, which is actually the solution found by the blockchain, that how this whole process is working. This Byzantine generals problem reach a consensus when 2 by 3 of the total generals agree that this is the correct time, and on this time we are going to attack. Let's analyze this. Let's see how the whole problem works. So if you see in this example, we have a commander who is passing on the time that we are going to attack at certain value. So he's passing on that we are going to attack at V time to each other lieutenant. And the lieutenant 3 is basically a Malin lieutenant who is passing on that instead of V time, we are going to attack at the X time. So he's trying to change the information which is being passed from here. So this is basically the general problems where we have a Malin lieutenant inside our solution who is trying to modify the whole situation here. So now let's analyze this again with our example. So in this image here, you can see that the commander is setting up the actual time, which is V to everyone. And then the lieutenant 3 is the wrong lieutenant here who is trying to make sure that this attack never successfully happens. There is another version of this problem that the commander himself is a traitor. So basically commander is making sure that different times are being sent across to different lieutenants. So lieutenants will never come into the consensus for the same. So again, this commander here itself is a traitor for the following situation. So there are two different possible cases for here. Now let's see that how the solution for this is defined. So if you look back to our first example here, where the lieutenant is traitor, let's say for now that commander, the commanding general, sends across the message that we are going to attack at 9 a.m. Lieutenant 1 receives this message that, okay, we are attacking at 9 a.m. Then Lieutenant 2 also receives this message that we are going to attack at 9 a.m. So let's just open up the notepad to analyze this in a much better fashion. So we have a commanding general who is sending the message that we are attacking at 9 a.m. So this commanding general is sending this message to the first person who is Lieutenant 1. So Lieutenant 1 here receives this message that we are attacking at 9 a.m. He sends across this message, the same message, to Lieutenant 2 that we are attacking at 9 a.m. Now Lieutenant 2 here is basically a wrong person here. Let's take Lieutenant 3 as a wrong person for now. So let's follow the example itself. So now this Lieutenant 2 is sending across the message to Lieutenant 3 that we are attacking at 9 a.m. Now the problem is that this Lieutenant 3 is basically a Malin person who is a traitor. So what he did, that instead of sending the same message, what he did, he modified this message that instead of we are attacking at 9 a.m., he sends across that we are attacking at 4 a.m. So he modified this message. So the future messages will be that we are attacking at 4 a.m. and they won't be able to attack. So this is not a good solution for us because just by sharing the messages, we are not able to come into a consensus here. So commanding general sees that, he's able to see that this is a problem here. So what he does is that he creates a new thing that whenever you are sending the message, you have to incorporate the previous message. So what happened? That commanding general sends across, we are attacking at 9 a.m. So here Lieutenant 1 receives this message. He sends across, he adds his message to the commanding general message. So this is the commanding general's message. Lieutenant 1 adds his own message here. So something like this, that commanding general says we are attacking at 9 a.m. and then Lieutenant 1 says we are attacking at 9 a.m. Now the Lieutenant 2 receives this. He also adds his own message to this. So he adds his own message like now Lieutenant 2 says we are attacking at 9 a.m. So now this message is sent across to Lieutenant 3, but this Lieutenant 3 is basically a traitor. So what he does, he actually sees that they have incorporated the previous messages. So he modifies everything by himself. So he modifies with his own entry that Lieutenant says that we are attacking at 4 a.m. and he modifies all the entries of the previous ones also. So 4 a.m., 4 a.m., 4 a.m. modifies everything. So again, this is not a good solution for us because he is able to modify the previous entries and then the Lieutenant 4 here will receive this one that we are attacking at 4 a.m. and everybody is saying that. So that means we will go and attack at 4 a.m. So again, no consensus is achieved for this. So commanding general notices this and he figures out a solution that this message which is present here, this message can only be formed within 10 minutes. So if some lieutenant is forming a message, he will only take 10 minutes to form this message. So if commanding general is taking, then he takes 10 minutes to form this message. Now Lieutenant 1 receives this, he adds his message within 10 minutes. Lieutenant 2 receives this, he adds his message within 10 minutes. Now Lieutenant 3 receives this. The problem with Lieutenant 3 arises that he has to add his message in 10 minutes. Then he will take 10 minutes to modify the previous lieutenant message, then the Lieutenant 1 message for 10 minutes, and the commanding general message for 10 minutes. So he's actually taking 40 minutes instead of 10 minutes. And this is the solution which comes to being, that when he takes the 40 minutes and he sends it across to Lieutenant 4, Lieutenant 4 will see that he was supposed to take 10 minutes, but he is taking 40 minutes. That means he is basically a traitor who is trying to modify the messages. So this person, this lieutenant, can be easily tracked across and be removed from the system. And that's how the blockchain concept also works. If you see the example here, these attack times are basically the blocks which are incorporated together, and each block inside Bitcoin will only take 10 minutes to form. If somebody is taking more time to form that means he is actually changing some kind of information inside the block. And this is the solution for our consensus inside the Bitcoin blockchain, that how the attack times and how the different things work together to form this. So if you look at this solution here, we have the same solution defined here, that general is saying attack at 9 a.m. Lieutenant 1 is saying attack at 9 a.m. incorporated with the previous one. And Lieutenant 2 is actually trying to modify that. So instead of taking 10 minutes, now he's going to take 30 minutes to modify that, and then anybody can see this. Now the problem here is that we have another kind of scenario where the commander is the traitor and he might send different orders to different lieutenants. Now the thing is that if he is sending different lieutenants some different orders, all the lieutenants will come into the consensus on the false order itself. So they will see that everyone is sending different kinds of orders. Somebody is saying attack at 4, somebody is saying attack at 9, and somebody is saying attack at 5. So they will go into the default option that we are not going to attack because we are feeling that something is fishy inside these messages. So they will just take the default option for retreating back. So these are the two solutions we created for the consensus algorithm. Now how this relate to the blockchain? This solution which we have described here, this is basically known as proof of work for Bitcoin blockchain. Each block which is being formed, it takes about 10 minutes to form, and they have the previous block hash appended in the current block which is being formed. Once this block is distributed to each participant has to agree on the block. If 2 by 3 participants or the actors agree on the block, that means the block can be stored over the blockchain and the verification of the whole process is done by the miners. So that's about the consensus algorithm and how consensus algorithm work within the blockchain. This is only the proof of work consensus algorithm which we have defined using the Byzantine generals problem. Other consensus algorithm might have some other different concepts. So in the next lecture, we will just discuss some of the major consensus algorithm and see how they differ from each other. So now we have discussed one of the primary consensus algorithm, which is proof of work, but there are many more algorithms available for consensus. The two major ones are proof of work and proof of stake. So what is proof of work? As you have seen in the last example for the consensus algorithm, there we have miners who are trying to solve a difficult mathematical problem, basically the guessing of the nonce value based upon a cryptographic hash algorithm. And once they guess that nonce value, they are able to confirm over the blockchain, and then the other miners or the other nodes which are present within the blockchain, they agree on it and the consensus will achieved, and finally the block will be stored over the blockchain. There are many different processes which could be part of proof of work. The major one which we use is basically a hash function where they are trying to guess the nonce value. We can also have integer factorization where they are present a number as a multiplication of two different numbers and they have to guess that. It could also be a guided tour puzzle protocol where the server suspects a DOS attack, a denial of service attack, and it requires a calculation of hash functions to make sure that the DOS attack will not happen on top of the server itself. So there are different things which might happen with this. Miners normally receive a reward once they solve this complex mathematical problem. Initially, the Bitcoin used to give it 12.5 Bitcoins for solving the puzzle, but now it has halved. So you will receive something around 6.25 Bitcoins for solving the problems. Miner, apart from that, also receives the transaction fees, which are part of the transactions which are put up inside the block. So miners make sure that they receive two things inside proof of work. The one is basically the reward for solving the nonce problem or the complex mathematical problem. And the second one is the transaction fees, which is put up with the transactions itself, which is addition to the rewards. If you see the example here, you can see that we have Alice, Bob, and Charlie here. They are trying to guess the nonce value and calculate the hash. Alice tries it, which is not correct. Bob tries it, this is correct. Charlie tries it, this is not correct. So Bob is the person who will receive the reward for the proof of work. So that's the main concept about proof of work. The second type of algorithm, which is quite famous apart from proof of work, is proof of stake. Why proof of stake came into being? Proof of work is a problem because what we do is that we actually depends upon the computation power. We require a lot more energy. We waste a lot of computer resources to calculate those hash values. We are continuously generating different hash values. If you see that within the Bitcoin world also, we employ so huge GPU, CPU miners, and we try to solve those mathematical problems to earn some rewards. But this is not a good solution for us because the problem here is that the proof of work is taking too much energy. Currently, the Bitcoin blockchain is taking energy which is greater than even the country of Switzerland and Ireland. So, which is very huge. So, we cannot take this solution forward. We cannot just keep on increasing the energy, keep on increasing the difficulty, and keep on solving those mathematical problems. So, we came into a new concept, which is basically a proof of stake. Proof of stake defines the algorithm that there is no block reward. There is only the transaction fees which will be shared by everyone inside the system. So when we say everyone, for example, I will just open this notepad again. So you will have a brief example here. Let's say I have a blockchain which has 100 coins. Alright. Then there are 4 users here. User A who has 20 coins inside the blockchain. User B who has 40 coins inside the blockchain. User C who has 30 coins inside the blockchain, and user D who has 10 coins inside the blockchain. So the main fundamentals of proof of stake is that you are going to earn only the transaction fees, but this is as per the stake you are holding in the blockchain. Something similar to how we do the trade or how we buy the stake in the stock market. So this is going to work in the similar fashion. So if you have 100 coins, let's say there a transaction occurs and this transaction has a transaction fees of $1. So how the differentiation and how this fees is going to be distributed? User A has 20 coins. So $0.2 will be allocated to user A. User B has 40 coins, so $0.4 will be allocated to user B. User C has 30, so $0.3 will be allocated to user C. User D has 10, so $0.1 will be allocated to user D as per the stake they are holding in the blockchain. So instead of block reward, we only define the transaction fees, which is distributed as per the stake they are holding in the blockchain. So that's the main concept about proof of stake, that people or the verifiers are able to earn the transaction fees as per their stake inside the blockchain. If you see the example here, this also defines the same thing. So we have the blocks which are validated as per the stake held by the person over the blockchain. The validator only earns the transaction fees and there is no complex computation. So this solves a major problem for us, which is actually arising under proof of work systems. So now what is the difference between proof of work and proof of stake? So with the proof of work, you can see that we are dependent upon miners and their computation powers to solve the block. With proof of stake, it's more of like the stake of the validators. With the proof of work, miners receive the block rewards and the transaction fees. With the proof of stake, miners only receive the transaction fees. There is no concept of block reward. Here in the proof of work, the problem is that there is one of the attack which is known as a 51% attack. So if any person inside the blockchain has 51% of the power of the total blockchain, then they can take over the blockchain. Here inside proof of stake, it works on the other fashion that the attackers requires actually 51% of the stake over the blockchain, which is very costly compared to proof of work. So two different concepts. Proof of work attack is basically the power. Proof of stake attack is basically the stake inside the blockchain. So those are the key difference between the proof of work and the proof of stake systems. So now we have seen the different concepts of blockchain. We have seen that how the consensus algorithm works. We have also discussed about two major consensus algorithm. Now finally, let's discuss the mechanism of the blockchain transaction. So how the whole blockchain transaction process works. This is basically the culmination of all the different concepts which we have talked till now. So how does a blockchain transaction works? Step 1. That you want to send some data or you want to send some currency to the other person. So what a user do, user creates a transaction from their wallet. Whenever we say a blockchain wallet, we are basically saying that the user has the private key and the public address, and they are attempting to send some data or currency to the other person. So they create a transaction which they want to send across. Step 2. This transaction which they have created is put across a pool of unconfirmed transactions. This pool of unconfirmed transactions are basically the transactions which are waiting to be processed by the miners. Once that is done, we come into the step 3, where the miners on the blockchain selects the transactions from these pools in a way that they are earning as much as possible, and they form a block at their end. This block is basically a collection of transactions with some extra metadata, and every miner who is present with the blockchain tries to form the same block. Multiple miners works on the same kind of transactions, and each of these miners actually compete with each other to solve that mathematical computation, which is basically the guessing of the nonce value. So under step 3, different miners are taking in the same transactions and they are forming the block at their own end. After this, the miners try to guess the hash value for the block as per the blockchain difficulty. So they try to solve the nonce value for the same. Once the block is created by any one of the miner, he generates a block signature by solving the complex mathematical problem, and then this block will be broadcasted to network itself. So each miner will receive that this miner has automatically found out the block. He has solved the mathematical computation. So you can just drop these transactions and move ahead to the next block and try to solve the next block here. So step 4 is basically that the block has been created. Miner generates the block signature by solving the complex mathematical problem, and then this block has the transactions which are being taken up from the transaction pool. Step 5 for this process is that the miners finds the target signature as per the difficulty, and they broadcast the block to every other miner and the node which is present within the blockchain. So each miner will receive this, each miner will verify the signature whether the block is valid or not, and then the other miners will just confirm the validity and agree on the block using the consensus algorithm, and then the block is finally added to the blockchain. This process, which is basically the step 6, is also known as the consensus. So again, going back, step 1, users create a transaction. Step 2, transaction is put up across a pool of unconfirmed transactions. Step 3, miners forms the block using the unconfirmed transaction. Step 4, miners compete with each other to solve this block. The first miner who solves the block broadcasts the block to every other inside the blockchain. Then the other miners verify the signature and they put up the same block with their blockchain, and they start working on the next set of transactions. So this is basically the process of how a blockchain transaction works. If you see the image here, this image is also giving you the same concept which we just discussed. So step 1, a transaction is requested. This is put across in the unconfirmed blockchain pool. Then a block representing the transaction is created. This block is sent to every node once the block has been confirmed. Node validates the transaction and they see that this block is correct. Once they verify and see this block is correct, the consensus is achieved. The node who has solved this, the miner who has solved this block, receives the reward for proof of work. Then this block is added to the blockchain and the distributed network is updated within the blockchain and the transaction process is complete. This is the whole process of the blockchain, but this is only limited to proof of work. If you have some other kind of blockchain project like Hyperledger or Quorum or Coda, they might have some different systems against it. So most of the blockchain projects take these fundamental concepts and just try to build on top of these fundamental concepts. Now coming to the transaction distribution, how the transaction is distributed, you can see three different kinds of transaction distribution here. The first one is the centralized one, which we currently focus on. This is basically that you have a central point and each other client or computer is connected to this central point. Suppose you are accessing google.com. So each person is directly accessing the same server. Then we have the second one, which is basically the decentralized one. Decentralized one is something like a torrent based system where you have multiple nodes who are storing the same data and the other nodes are connected to each other, to that node. So here you can see this 1, 2, 3, 4, 5, 6 and 7 are the major nodes who are holding the data and every other computer is directly connected to these nodes. So this is basically a decentralized where instead of just one single centralized party, now we have like 7 or 8 different centralized party. Now coming to the blockchain one, which is basically the distributed, which states that each node is connected to the next one. So everyone is hosting the same data. If even one single node is updated, this data is going to be synchronized with the whole network and every computer within this network will be updated. So this is basically the distributed one, which we are moving with the blockchain. Centralized one is currently being used in multiple services. Decentralized is also being used under peer-to-peer networks, and then distributed is basically that everyone is holding the same information and they are working on the same information, which is being followed with the blockchain. So that's about the transaction distribution. We have seen now how the blockchain works. And we have also gone through the different consensus algorithm which are majorly available in the world. So whenever you work with blockchain, there are different entities you are going to work with. In this lecture, we are going to detail out the complete blockchain ecosystem and what are the different entities which you are going to work with while you work with the blockchain project. So the first and the most important entity which is going to be part of your blockchain ecosystem are the blockchain projects. These are the major projects that are running the blockchain throughout the world. The first one is the Bitcoin project. Bitcoin project is the one which introduced the world to the blockchain. This is the project which created the cryptocurrency back in 2009, and everyone understood that what blockchain actually is and how to use blockchain for their own use cases. The second important one is the Ethereum project. Ethereum project is different from Bitcoin because it brings up the concept of smart contract between two parties. Ethereum blockchain recognized that Bitcoin has a problem that two parties cannot agree on certain rules. Everyone will be able to see those rules. So Ethereum project created the concept of smart contracts where two parties can agree on certain rules and they can create a trust by using a smart contract. After that, we also have Neo. Neo is more of like a Chinese Ethereum. It bought Python as one of the main language for creation of the application. And finally, we have Hyperledger Fabric, which is a very major project under enterprise graded blockchain solutions. It is programmed through JavaScript, Node.js and Go language, and it's a modular project which supports multiple consensus algorithm and can be used for multiple use cases. So having a blockchain project is a must for blockchain ecosystem because that is the main entity on which everything is going to work upon, and most of the applications will be built upon the blockchain project. After blockchain project, we have blockchain users. Blockchain users are normal users like you and me who are going to use blockchain or cryptocurrency to achieve some results. It could be investors, it could be normal users, it could be application users, it could be any kind of users who are using blockchain. Suppose, for example, you are creating a blockchain for a ticketing based system. Now you want to sell concert tickets using blockchain. You require users who can interact with your blockchain and buy and sell the concert tickets from your blockchain platform. That's why blockchain users are must. If you have only the project and you don't have a user base, or you don't have a utility for your blockchain project, then your blockchain project might not grow in the market. So blockchain users are must for any blockchain ecosystem. They are the ones who are going to do the transactions. They are the ones who are going to upload the data over the blockchain, and they are the ones who are going to interact with your blockchain applications. Even Bitcoin has multiple users throughout the world. Bitcoin serves the major utility of payment of goods and services, and it is being utilized by Microsoft, PayPal, and Subway. Bitcoin was the first mover in the blockchain. That's why it's have a high utility, but the current projects are more on the enterprise capacity. So enterprise users are becoming blockchain users for blockchain projects. After blockchain users, we have blockchain exchanges. Every blockchain project has a robust ecosystem working under it, and it will include a decentralized exchange for the exchange of different tokens. Most of the blockchains project are based upon that you are creating tokens which are interacted by the users. Let's again go back to our example where we have a ticketing system and you are creating the tokens so that the people could purchase concert tickets from your blockchain project. Now these tokens have to be bought from somewhere, and that buying process, that process where the people are selling their tokens and some else is buying, is basically happening on a blockchain exchange. There are many exchanges working throughout the world. If you are creating a blockchain project, you can also create your own exchange which will make sure that people are able to transact the same. It's more of like a bank where people are transferring money to each other. So blockchain exchange also works on the similar principle. The difference is blockchain exchange work on the principle of supply and demand. So if somebody wants to buy any tokens from blockchain exchanges, then there should be a second person who is willing to sell their tokens over the blockchain exchanges. Blockchain exchanges are more of like a trading functionality, and they can be integrated with different kinds of wallets, or even users can create their own wallets for the exchange website. Some of the popular blockchain exchanges are Binance and Bittrex. After blockchain exchange, we also have blockchain verifiers. You have seen in the consensus algorithm that how blockchain verifier or miners work. They maintain the integrity of blockchain by making sure that everything is verified while you are working with the blockchain. Blockchain verifiers mostly run independent nodes throughout the world. For example, in Bitcoin, they are running a node to solve a calculation based upon the nouns. In private blockchain, it could be that a central organization has the authority of the different nodes. So it depends upon your project, how your project is functioning, and you will incorporate blockchain verifiers with your project. Apart from running the nodes and verifying the system, blockchain verifiers also receive some kind of incentive to make sure that they are earning something for the work they are doing. So if you are verifying something over the blockchain, then you might receive an incentive which may be based upon the block rewards or the transaction fees. And these blockchain verifiers always works on the functionality of consensus algorithm. It depends upon your blockchain project that how consensus algorithm is going to function for your use case. It could be that you are using proof of work. It could be that you are using proof of stake, but they have to have some kind of consensus algorithm under that. According to that, they will function throughout your blockchain project. Apart from all these entities, we also have blockchain developers. Normally under blockchain, we have two types of developer. One is the normal blockchain developer and the other one are known as dApp developers. The normal blockchain developers are the one who are going to create new blockchain projects, functionalities and consensus algorithm. They are the ones who are actually managing the blockchain project and creating all the different functionalities which are required for the blockchain project. On the other hand, the dApp developers are more of like the developers for decentralized applications. You can take the analogy something like Google Play Store, which is built upon blockchain technology. So you can deploy multiple applications over the blockchain. DApp developers mostly work with both the things. They are going to work with the smart contracts and also work with the front end for the application. The development of smart contracts over the blockchain was possible with Ethereum blockchain, but currently most of the blockchains are applying smart contracts for interacting between multiple users. So two different kinds of developers, the blockchain developers and decentralized application developers. Then finally, we have blockchain applications. Blockchain applications are the major interactive point for blockchain. Even though if you have everything built upon your blockchain, you require some kind of front end. You require some kind of interface where the users could interact with your ecosystem. And that's where blockchain applications come into play. Everything related to developers, project, miners, and exchanges work together to serve these blockchain applications. There are various applications throughout the world. Some of the important and the common ones are listed here. CryptPad, which is a very good example. It's a decentralized document creation application, something similar to Google Docs. Then we have Human IQ, which is a fintech startup for connecting unbanked people throughout the world. Then there is Agure, which is a peer-to-peer based oracle and prediction marketplace. And then we have Filament, who is building IoT applications over the blockchain. These are making great strides in the blockchain world, and you can definitely go and check these applications out at your end. So now you have already gone through what blockchain is and what is the different entities which work together to form the blockchain ecosystem. Now let's talk about why industries need blockchain, why this technology is so much important for industries, and why should they get on board to utilize their use cases over such a technology. So these are some of the current blockchain implementations which we want to discuss about. So under pharmaceuticals, DHL is working with Accenture to establish a blockchain based track and trace system for different areas worldwide. Currently, their system has 7 billion unique pharmaceutical serial numbers, and they are handling more than 1500 transactions per second. So they are making sure that by using blockchain under pharmaceuticals, they are building up a solution where they are easily able to track all the counterfeit products. And moreover, they will have a traceability maintained for all their products throughout their capacity. The second current blockchain implementation is with the fashion. So CGS has developed a system for tracking garments and compliances on raw materials for different apparels and fashion clients. CGS is using blockchain for tracking the apparels. They have their barcodes for the apparels, and it's very easy for them to upload those details using the barcodes over the blockchain. And then they are able to track the apparels, that what is the movement of the apparel, what is the complete supply chain the apparel is following from manufacturing to the consumer. Then the third important one which is implemented are the cross-border payments. Cross-border payments have been working in multiple blockchain projects. One of the important one is that IBM has developed a new banking solution which allows the financial institutions to quickly and cost-effectively process the payments globally. Then there is also solutions based upon Coda and Hyperledger blockchain. There are solutions where people are even buying and purchasing the trade goods using the cross-border payments. Then we have food safety. IBM has partnered up with Dole, Nestle and Walmart to set up the blockchain for food regulation. One of the implementation for the food safety one is with the Walmart, where they have employed Hyperledger Fabric for tracking and tracing their food products from the manufacturing end to the retailer end. And this is one of the important project which is happening, because initially their total cost and total time for tracking the food products was very high. They used to take about 21 days to track the food products, but now they have reduced it to 2.2 seconds, which is very high compared to the previous project. Then we have United Nations. United Nations are currently using blockchain for 16 different agencies, including human trafficking and World Food Program, which is very important for United Nations because these kind of things are affecting and losing a lot of money throughout the world. Jewelry has also come up with the blockchain. Jewelry, something like Brilliant Earth, has partnered up with Everledger to use blockchain in tracking and tracing the provenance of diamonds and other gemstones, and this will ensure that it's conflict free. In the jewelry market, there are a lot of conflicts related to the provenance of the diamonds, whether this is the correct diamond or whether this will be regarded as a good diamond or not. So through this business, through this Everledger partnership, Brilliant Earth is able to track across the provenance, and they are making sure that they are conflict free throughout the process. Now, talking about the blockchain revolution, how the blockchain has come up to play till now. The first thing blockchain started was with cryptocurrencies. Bitcoin started in 2009 and it brought the concept of cryptocurrencies. This was very new for everyone, cryptocurrencies, because it's a digital payment gateway. Before this, there was one more solution which started in back 1980s, where Microsoft was trying to utilize some kind of digital currencies so that people could use them under their Windows environment. But that didn't came into play as such, and it was shut down by 1999. But now this Bitcoin payment system was much more different than the previous system, because the Microsoft one was centralized control. But Bitcoin brought up the concept of decentralization, and people are controlling the currency instead of some central authority controlling the currency. So that's why cryptocurrencies started up the whole concept of blockchain. We have the payment services and trade of resources, which were bringing up different concepts and which were showcasing that how you can use digital payments or digital coins for doing transactions for purchase of goods. Once that was established, the Ethereum blockchain owner, Vitalik Buterin, realized that this Bitcoin solution is not a concrete solution. If I want to do some kind of activity between two or more persons, then I cannot hide it from other people. But in the real world scenario, we require contracts. We require contracts for doing anything. If you get a job, you will sign a contract. If you are working as a freelancer, again sign a contract. If you provide a project, again there is a contract. So everything is contract based, be it your sports, be it your profession, be it your legal services, everything is contract based. So Ethereum blockchain realizes that, and they created the concept of smart contracts. So the second revolution for blockchain came into being was more of like the smart contracts, where people started using smart contracts between two parties. They need to agree for different rules and services, and then they can create a smart contract, and then those smart contracts started using token based system for transaction between the users. So what is the difference between cryptocurrency and a token? It's more of like, let's say you have US dollars and you are buying apples, and on the other hand you have US dollars and you are buying cars. So your US dollars are the cryptocurrencies. The cars and apples you are buying, you can take them as tokens. So the functionality here, it is defined as such that you cannot purchase cars using oranges, or you cannot purchase oranges using cars. You have to use US dollars to buy those things, but you can exchange cars between each other. You can also exchange oranges between each other. So that's the concept of tokens. Tokens acts as your oranges and cars in this example, and cryptocurrencies is more of like US dollars which you have. So they brought up the concept. There are many more examples for smart contracts which are happening. One of the primary one is renting the houses. So you can easily enable the smart contracts for renting the houses. With this token revolution, we also came into the concept of ICOs, which was basically something similar to IPO, but it was raised with cryptocurrencies. Many different organizations started using ICOs to build up their base, get some kind of funds inside their organization, and then start building the project using the same. Now, this blockchain revolution is completely working as the web revolution. If you remember, web revolution happened in a way that we have web 1.0, then we have web 2.0, and currently we are inside web 3.0. So different kinds of revolution happened throughout our web interface. With web 3.0, we have the concept and we have the different organization which came into being, such as Amazon, Google, Facebook, etc. With blockchain also, we are moving into the phase of web 3.0, 0, where we might see those kind of applications like YouTube, LinkedIn, and Facebook over the blockchain technology itself. So blockchain revolution, the third step, is basically going to be your dApps and enterprise, where we are going to have decentralized applications which were hosted on blockchain, and these decentralized applications will be used for interacting with different kinds of services. Why decentralized applications are important compared to the centralized applications? Because they are going to create a world where we don't have to trust a central authority. We are more trusting towards the algorithm itself instead of trusting the central authority. We will also come into the concept of autonomous organizations, which is more of like people are working independently and they are not dependent upon any kind of individual or services. So that will be a very good effect for our pandemic situation also, where we can create autonomous organization and we are not dependent on going to the offices or having some services enabled for us. Now, after learning about the different kinds of revolution and the current implementation, let's talk about the exciting disruptions which industries could look upon and they could work upon. So one of the important one is entertainment industry. There is only one example which we have listed here, which is the movie Braid. So the movie Braid was the first movie which was produced by doing an ICO. So they did an initial coin offering and they sold the rights for the movies for Braid movie. And what happened with this was that people who actually invested in the ICO, they were earning from the movie ticket sales. So as much as you have invested under the ICO, you were getting the same percentage from the movie ticket sales. So that is one of the important thing could happen. This is good for independent movie makers because they don't have those kind of funds. So they can create an ICO, raise the funds, create the movie, and the people who have invested in the movie could earn from the same. Then we have property rental. Property rental is a major one for blockchain. Rentberry is working with this. They aim to address the common pitfalls and headaches of traditional rental model. And this is a good solution because what does this solution brings you? That let's say you have an owner who wants to give his property for rent, and then you have a leaser who wants to rent the property. So what could happen that the leaser could store the money inside the blockchain, and till the point the owner don't hand off the keys to the leaser, till that point the money will be part of the blockchain itself. So we can have some kind of store bank created in the blockchain which we can use for the property rental. Then politics is also a major one. Sierra Leone is the first who carried out elections on blockchain. And why doing elections on blockchain is profitable? Because it brings up the transparency. Everyone can see that who is winning, how the election process is working, and how the different votes are casted over the election process. So this was the one. And moreover, by using blockchain, Sierra Leone makes sure that nobody is able to actually modify the data, because the data is stored independent from the modifications, and nobody can actually update or change the data with the blockchain. Then there is education. Socrates coin is doing different things under the education. They are bringing the concept of 3D internet. So they are building up the different bases for doing education over the blockchain. Another important one is that you can create something like courses or educational material using blockchain. So different people connected to each other create their own education material, and then they can share between each other. That would be a very good use case for education too. Then we have digital advertising. Basic attention token is using digital advertising to solve the problems with the blockchain. So what they are doing is that they are building a kind of a rainbow table over the blockchain, where they have created the links for different sites and how the advertisements, or what is the costing of advertisements over the sites. People can challenge those advertisements, people can buy those advertisements. So they are creating a trusted source or a trusted list where you can refer to the digital advertisements. Finally, we have Internet of Things. Walton Chain, a Chinese project, seeks to integrate IoT with blockchain technology, and and they want to make sure that each IoT devices have their own blockchain node working with them, so they can communicate the data and synchronize with each other. So it's very easy for them to track the different IoT devices under a manufacturing plant or a unit. So these are the different disruptions which could happen over the blockchain. And if you have a brief look at the different disruptions, you will realize that it's very important for industries to move the blockchain, because the next revolution is on the way and we are going to move ahead with much more bigger applications over the blockchain. We are moving from the concept of centralized to decentralized and distributed, and industries who are up on these concepts will be much more ahead against the central authorities. So that's the main part why industries need to adopt blockchain and utilize blockchain under their use cases. So now we have seen that why industries need to adopt blockchain and utilize blockchain for their use cases. Although industry is required to go on board with the blockchain, but there are different challenges which industries might face for blockchain adoption. So let's discuss those different challenges. So the first important challenge most of the industries face is about energy consumption. If you have a look around the blockchains who are using proof of work algorithms, you will notice that there are very heavy machines who are actually trying to solve the nonce value for the verification of the blocks and then uploading the blocks over the blockchain. Proof of work utilizes very heavy computational power and solves some complex mathematical puzzles to verify the transactions. If you take the example for Bitcoin current energy consumption is almost equal to the country of Ireland. And by 2020, that means by this year, Bitcoin will have more consumption of the energy than the entire world. So this is a very major challenge for adoption of blockchain, that the energy consumption for blockchain is very high if you are going to go with the proof of work algorithms, and you have to put up very heavy machines to make sure that the verification of the transactions for your projects are working. There are some solutions throughout the world. A probable solution has emerged in the form of different consensus algorithms. So instead of using proof of work, you might go ahead and use proof of stake or delegated proof of stake. With proof of stake, the verification is based upon that how much stake you have on top of the blockchain. So this will take out the complex mathematical computation and shift it to more of like stake-based organizations. Another important thing to notice for industries is scalability. Blockchains are currently not known for their scalable behavior. Scalable is one of the significant issues if you are going to go with the blockchain networks like Bitcoin and Ethereum. Why scalability is an issue? Because blockchain normally supports multiple users, multiple exchanges and multiple applications. So it's very heavy for them to manage all these users, applications and different exchanges over the network. For example, the Bitcoin is currently almost the size of 150 GB. So as a new user, if you are going to join the Bitcoin solution and if you want to transact something over the Bitcoin blockchain, initially you need to download that 150 GB of data to your machine. Only then you will be able to do all those processes. Blockchain is more of like everything is recorded and everything is available. So basically what you are doing is that you are downloading the whole blockchain. If you read across the data, you will be able to see the first block which is started by Satoshi Nakamoto till the latest block which is present today. So these blockchains are more and more effectively being used, where we are downloading the whole data and then we are transacting with the blockchain and uploading new data on top of them. There are some solutions available for them. Supposedly there is one solution which is storage of hash of the data over the network instead of the actual data. So the size of blockchain will reduce to a very great extent. There is also a solution of using a lightning network, where you are creating another virtual layer or a virtual blockchain over the main blockchain to make sure that this virtual blockchain is on very light context compared to the main blockchain. Then there is also point-to-point storage of blockchain. So let's say you and me are doing the transaction. So you and me are only going to store the transaction in our blockchain. Nobody else is going to store the transaction. This kind of behavior is employed with blockchain platforms like Coda blockchain. So there are some probable solutions to interact with the scalability too. The third important challenge which industries face is public perception. Blockchain technology started with cryptocurrency and it built up the perception for the blockchain synonymous to the Bitcoin. Majority of the public is oblivious to the existing potential use cases of the blockchain. They only think about the process that Bitcoin is basically anonymous and used for shadow dealings of money laundering or black market trade or other illegal activities. And so blockchain is getting a bad reputation because of the cryptocurrency. And it's very common. Even if I go ahead and tell my family that I work with blockchain, then they won't be able to understand. But if I tell them that I work with Bitcoin, then they will easily understand that, okay, now you're working with the cryptocurrencies. So that's the public perception. People think that blockchain is cryptocurrency, but cryptocurrency is just one of the use case for the blockchain, and blockchain holds the real potential compared to the cryptocurrencies. We can use blockchain in multiple processes and build up multiple applications using the blockchain. So that's the main part about adoption of blockchain. Mainstream adoption requires us to remove all these negative undertones of cryptocurrencies, and only then we will be easily able to employ blockchains with our industry capacities. Another important challenge for industries are standards and regulations. This is one of the major ones because blockchain is a new technology. Most of the governments and countries are skeptic about it. They are not able to figure out that what are the proper definitions of standards and regulations for the cryptocurrencies and the blockchain. Enterprise and governments are mostly working under a regulated way. They are more centralized control. So that's why they are not able to adopt blockchain as such. They are not able to change their processes because blockchain is bringing up the concept of decentralization and transparency. So enterprise and governments are skeptical about using the blockchain because they need some kind of control. They need some kind of regulations over their products which are being provided under the country. Several countries have actually created their own regulations to tackle this problem, but still it's almost been 11 or 12 years when blockchain started, but still the whole process of blockchain is not adopted and not regularized by different countries. Some of the countries have even banned the use of cryptocurrencies and blockchain in their world. So it's more of a process there where the countries and the enterprises are not able to figure out that what are the different concepts they need to adhere to, what are the different regulations they need to adhere to, and what are the different things to make sure that they are able to utilize the beneficial points of blockchain under their own industries. So mass adoption of blockchain might be able to standardize this product. If you have a look at the Gartner curve, you will recognize that the mass adoption is actually based after 2024. So this is more of like a learning period for everyone. Everyone is learning about blockchain. Everyone is just doing proof of concepts, getting their hands dirty with blockchain and figuring out how to use blockchain. And by 2024, we will have many more applications built on top of blockchain. So it's very important for you because if you learn what is blockchain and how blockchain works in today's concepts, then you will be easily able to get on top of the curve by 2024 and ride the wave to success. So that's the main part about different things which are working with blockchain. So these are only some of the regulations which we have discussed here. In industries normally have their regulations related to use cases too. Like some of the industries might have regulations where they might say that we don't want to build our financial systems outside the countries. It's very common for Arabic countries to do that they want to hold their solutions for money transfer inside their country. So they won't allow to build up the blockchain nodes which are outside the country. There are also regulations for interactivity with the data, that how much data could be sent across and how much data could be received with the blockchain. So there are many different things and many different challenges compared to the implementation of blockchain, and you need to figure out as per your use cases that what are these challenges and how you are going to tackle those challenges. So now we have gone through the main distribution of the blockchain. We have understood the fundamentals which actually constitutes the blockchain. We have seen the concepts of blocks, transactions, and consensus algorithm. Now let's analyze blockchain using some of the blockchain examples. So one of the primary example for blockchain which is working under the real world is basically Walmart. So Walmart is using the blockchain to track their food products. Back in 2014 and 15, there was a major problem with Walmart that there was a disease related to spinach in US, and they were not able to understand that which batch of the spinach actually has those disease. So what they have to do, they have to actually track back all the different batches for the spinach. Now, this is a major problem for them because they have to track back all those batches. So there is a cost associated with that, and they were not able to figure out how to track the food. So they ran into this problem and they thought of this, and they thought that let's employ blockchain to solve this. So they appointed Hyperledger for such a solution. What they did, they created a blockchain solution for food traceability using Hyperledger Fabric. They ran a POC with IBM for tracing mangoes in Walmart US store first, and also they wanted to trace pork in China. The tracing process using the blockchain, because now what happened, once they start storing the data over the blockchain, it was immutable data and it was transparent data which was available to everyone. So they were easily able to track that which batch is actually produced from which kind of outlet. So that was the major thing which happened, and they reduced their tracking process from 7 days to 2.2 seconds, which is very huge. The major benefit they got from this, that now they have a very faster and protected process for tracking the food products. Moreover, they were able to increase the livelihoods of farmers because now they can directly get the farmers on top of their blockchain, and they will be able to see transparently that how the whole process is working. So this is one of the major things which Walmart implemented. If you see the example here, this is the example of the supply chain which Walmart is using for food traceability. So what happened was that initially, once a product is created, then the information about the product like certificate of origin, batch numbers, processing data is stored on top of the blockchain. So this has some kind of transaction ID associated with that. After this product is basically shipped to some other location. So you have some information like barcode, shipment date, order number, everything is being directly stored over the blockchain. The main process to notice here, this is basically taking the last transaction and including it with that transaction. So it is taking the input as the previous transaction and including a new transaction on top of it. Blockchain also works in the similar concept. Like if I send across $1 to you, then you are going to take that transaction and create a new transaction to send some money to your friend. So that's how the blockchain concept also works. So they are taking the one transaction and incorporating it with the new transaction which is created. So they have a traceability maintained. If somebody wants to see, he can see the previous transaction information also. Now they came into the third concept where they had some kind of warehouses. So they again included the data for warehouses like certificate of origin, batch numbers, production data, and they included with the blockchain itself. And with this warehouse of data, they also appointed a third party, which is basically quality check specifications or some other invoices or shipment information. So they had third parties who can easily track whether all this data is stored correctly on top of blockchain or not. Once that is done, again the shipment happened. They had the shipment date, order number, temperature, barcode for the food which is being shipped. Again, this transaction is just in link with the previous transaction, so anybody can see this. Then they have some kind of cargo facilities available. So they have order number, shipment number, equipment number, and temperature, which is appointed, again stored as a transaction over the blockchain. This is being sent across to the retail houses, where the retail houses will have some kind of receive date, pick date, packaging specification, packaging barcode, and temperature of the food product. Again, a new transaction is created on the previous transaction itself. And they also have third parties which will check across against the quality and the inventory levels of the retail houses. So they have the whole process transparently maintained, where all the different parties under their supply chain were able to store the information over the blockchain and also track that information. Finally, the shopping, their Walmart outlets receive that. Then Walmart outlets also have the receive date of their food products, order number, invoice number, customer ID to whom they are selling it, and the temperature. And they were able to track from customer to the process of manufacturing. So even a customer can see this process that, okay, I have bought the pack of mango slices, or I have bought pork. So I can track that what is the origin of this pork throughout the process using the blockchain, because what is happening, all these transactions are interlinked with each other. So we can easily track to the starting point. This is also the concept of blockchain. If you see the Bitcoin, you can easily track back to the first transaction which was created by Satoshi Nakamoto in 2009. And that's the concept which we are using under this process also. So this is a very good process which Walmart created for tracking the food traceability. Another real world example is a Honeywell marketplace. Honeywell marketplace is basically, the problem with the Honeywell is that they wanted to cut the purchasing time for the aerospace product. They figured out that if we are selling aerospace product, it is actually taking many days and weeks to actually conduct the transaction. And moreover, the physical parts and all these things, the digital equivalent of the physical parts, they were not able to specify how to connect them and how to process them. So what they did, that instead of using this, they created an online marketplace based upon Hyperledger Fabric blockchain for tracking the new and old aircraft parts. They created a trust system with cryptography. Most of the purchases happened using the bonds itself on top of it, and the seller can easily launch his own selling system for selling the aircraft parts using the Honeywell solution. So this is a very good solution created by Honeywell. So if you go to this solution, this is known as Go Direct and created on Hyperledger Fabric. So you can also act as a seller on top of it if you have aircraft material to sell across to different organization. And this is a process where you can actually define the digital equivalent to your physical part. So you can create the bonds on top of it, which is going to act as the equivalent to your physical aerospace part. And the benefit by using such a solution was that the time was reduced for selling the airspace product from days to minutes. Moreover, it made sure that we are easily able to counter the anti-counterfeit measures. What normally happens in the aerospace, there is some kind of leakage of information. There is some kind of false or graded aircraft parts which are delivered to different organizations. So we were not able to track that what are these false and graded different parts which were being delivered to different organizations. But once we set up the process where the data is immutably stored on top of the blockchain, we were even able to counter such activities with this. If you see the example, this is the Go Direct Trade example by Walmart. So they have the concept of listing the event, history of the event. They also have repair and overhaul the event. Then they have the birth of the event and the dismantlement of the event. So you can track everything using that. If you see here, this is a trust trace created here, where by date they have tracked across all the things from the conception of the aerospace part to the process where they are actually repairing it and also dismantling it. Everything can be tracked across here. Moreover, the prices here which are labeled here, these can be verified by the different verifiers inside our blockchain process, so they can make sure that the sellers are not asking for a higher price. They are under the reasonable consideration for the aerospace part. So this was also one of the major solution which is created by Honeywell using the blockchain to sell across the different aerospace parts and make sure that nobody is able to actually attack or modify the parts or even deliver some of the damaged parts to different industries. How this whole process happened, you can see the process example here. So you have a mobile phone or a web application where you create a request. This request is basically transmitted across a peer-to-peer network system using the nodes. Then this request is being verified by some kind of verifiers who are processing this request and solving it, and then putting up the digital tokens as records for the aerospace parts on top of the blockchain. Once everything is verified, the transaction is combined with the previous transactions, which are basically recording the information for the previous history of the aerospace parts. Then this new block is added to the blockchain and the transaction is complete for selling and buying of the aerospace parts. So this is one of the major examples which is also using blockchain. These are just some of the examples which are being used with the blockchain. There are many more examples There is Bank of Monte Carlo, who is using the blockchain for banking solution. There is Belgium and Switzerland, who is actually using the blockchain for payment of taxes. There is also Guatemala, where they are using blockchain for conducting the election process. There are many more places where the blockchain is being employed. Another important blockchain is being used is for tracking of jewelry. So once the jewelry is being mined at different locations, so the start of the stones which are being mined to the process where they are delivered as a finished good to the customer or the client, the whole process is also being tracked on the blockchain itself. So Dolls is one of the company who is using the blockchain for tracking the jewelry. So blockchain has many more advantages compared to the cryptocurrency. Cryptocurrency is basically just a use case for blockchain. Blockchain is the real technology behind it, which can be utilized for doing multiple other things. Why we can use blockchain? Because it creates a new kind of system. Instead of forming a centralized system, we are forming a distributed system which is away from the intermediaries, and we can easily then use this system to trust this system and then use it against other multiple use cases. So those are some of the important concepts and example of blockchain. With this course, we just wanted to make sure that you have a clear understanding of the blockchain fundamentals. Once you have gone through this course, now you can go into the advanced version of the blockchain courses where you can study about the different blockchain projects or even create your own blockchain solution or currency. So that's about the blockchain course, guys, and we hope that you have enjoyed our blockchain course, and glad to have you with us. Thank you. Have a good day.
I want to introduce you to Great Learning Academy. This is a free initiative by Great Learning where you can have access to over 200 plus courses with 1000 plus hours of free content on all of the trending high demand domains, absolutely free. Register now to complete the course and get your free certificate of completion as well. Check out the link in the description box of the video below for more details. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.